Good day, everyone. I am Abishai. Today, I am going to present to you our Thermodynamics 1 group project code VDA 20703 regarding about pump. Our lecturer for this course is Encik Mohamad No Anuar bin Mohamad, and we are from section 9, group 1. As you can see here, our group consists of 5 members. Firstly is FIRDAUS, second is me, Abishai, third is AUNI, fourth is Daniel, and lastly is AHMAD.
Assalamualaikum and a very good evening. My name is AHMAD FAKHRUDEEN and I will continue with the introduction. Uh, the study of the first law of thermodynamics and steady flow devices has become an important area of research in the field of thermodynamics and mechanical engineering. Researchers have used the steady flow energy equation to analyze a wide range of steady flow devices, including pumps, compressors, turbines, and heat exchangers. They have also developed methods to improve the thermodynamic efficiency of these devices, and have studied the effects of various operating conditions on the performance of a steady flow device. And for the objective of this study is to fully comprehend the relationship between the theory and the applications. And the second one, to simulate the energy variation involved in the system with SSFD, which is steady flow device operated under various parameter changes. General General review. For the general review, pumps are a common steady flow device. They example of a steady flow device from one location to transfer fluid from one location to another by increasing the pressure of the fluid. Is the mechanical energy supplied to the impeller, which is used to increase the pressure of the fluid. Energy supplied to the impeller, which is the increased pressure of the fluid, which causes the fluid to flow from one location to another. Any energy loss as heat is causes small and is often ignored in steady flow device analysis. To flow from one location Understanding to the first law of thermodynamics and its application to steady energy loss device is crucial for the design, typically small and maintenance of this machine in the steady flow device analysis. For understanding the first law of thermodynamics and its application to steady. Thank you. General
Hello, Assalamualaikum. My name is ZAINI and I'm going to explain about the review of first law as steady flow devices, which is SFT. So, the first law of thermodynamics is a thermodynamic adaptation of a law of conservation of energy, which is the total energy in the system remains constant, even when it may be transformed from one form to another. It is a straightforward expression, which is energy cannot be created or destroyed. It's another frequently used phrase. So it's actually distinguished in principle to form of energy transfer, which is heat and thermodynamic works for a system of a constant amount of matter. So the law also defines the internal energy of a system and extensive property for taking account of the balance of energies in the system, and the law of conservation of energy states that the total energy of any aspect of the system which cannot exchange energy or matter is constant, and energy can be transformed from one form to another but cannot be created or destroyed. So for the next part, pipes, nozzles, devices, and pumps are a few examples of constant flow equipment. In most cases, a gas or liquid is a substance passing through the device, and if the device alters the fluid velocity in any manner, the fluid will exert force on the steady flow device in response. And during steady state operation of a device, such like the thing that I said just now, which is pipes, nozzles, devices, and pumps, and any system property within the control volume is independent of time. Therefore, the internal energy of the system enclosed by the control volume remains constant.
Assalamualaikum and hi. My name is ZAKIRAH. I will explain about the application of SFD, which is steady flow devices, which is pump. The first one is the wastewater pump. The wastewater pump is used to move highly contaminated liquid that frequently contains solid of different types of solid, which are organic, inorganic, and also the mineral origin. The second one is actually air conditioning system. The liquid is drawn toward the motor as it rotates due to the centrifugal force it produces, and is discharged into the opening of the wallet. The third one is refrigerant system. The primary refrigerant cools the glycol or brain. Waste is then used to transfer heat without changing its state. Reciprocating this secondary coolant involves the use of certificate clear liquid handling pump. The third one is chemical feed pump, a compact positive displacement pump called a chemical feed pump. It is also referred to as a chemical dosing pump. It is used to precisely inject chemical or other substances into water, gas, or steam. The last one is pump in marine services. Since the centrifugal pump have high flow rate and can handle water form quickly, they are frequently used as a ship fire. So, uh, in this event of a ship fire, it is crucial that enough water be on hand at the proper pressure and that as a backup plan to be put in place in case of fire pump stop working or it is inoperable.
Hello everyone, it's me again, Abishai. For case study, simulation of steady flow device, a Python code in Google Colab that we created helps us to calculate the energy balance of a fluid passing through a pump by using variables such as density, pressure, velocity, and power input. It first prompts the user to input density, pressure, and velocity of the fluid at the inlet and outlet of the pump, as well as power input to the pump. It then calculates the change in kinetic energy, also known as dk, using the density and velocity at the inlet and outlet. It also calculates the change in potential energy, also known as dP, using the pressure at the inlet and outlet. Next, it calculates the work done by the pump, also known as work underscore done, by dividing the power input by 1000. Finally, it calculates the energy balance by adding the change in kinetic energy, change in potential energy, and work done while displaying the final energy balance value. Our code also presents a graph in the form of scatter plot, with a change in kinetic energy plotted on the x-axis and a change in potential energy plotted on the y-axis. The energy balance represented by the colors of the points.
Hi, so I will continue the presentation, which is the conclusion. So, in conclusion, the first law of the thermodynamics is a fundamental principle that governs the operation of pump and other steady flow device. It states that energy cannot be created or destroyed, only transferred or converted from the one form to another. This law is used to analyze the thermodynamic efficiency of pump, the operating of pump, and to design and optimize the performance of pump. The understanding of the first law of thermodynamics is crucial for the design, operation, and maintenance of pump and other steady flow devices in various industries such as power plant, HVAC, chemical, and water treatment plants. So that's all from me. Thank you.
Alright, that's all from us. Thank you for listening to our presentation, and if you have any question, please contact us.